Okay. So welcome. My name is Piotr Gołkiewicz. I'm customer consultant at Life Science Solutions Elsevier in Central Eastern Europe. If you are in academia or government institution, please feel free to reach to me if you would have any further questions related to life science solutions in Reaxys in particular. Today, we really will concentrate on Reaxys, on chemistry. So this will be chemistry intensive presentation for those who are not prepared for such a dose for chemistry. Then please bear with us and see where you can find the benefits for you. But I hope we have lots of chemists and related sciences on the call. I'm recording this, so maybe we can share it later for those who are not able to make it. Also, please feel free to ask questions in a Q&A option you have in a Zoom here. So feel free to ask questions. I will try to leave some time at the end to answer the questions. Okay, so let's start. Let's go and let's talk about chemistry in SDGs. Let's talk about Reaxys. So maybe we really start from talking about Reaxys and what is it and how this, what's the history of Reaxys and why is this such a great tool? Reaxys comes from very old content. It contains very old content, starting with all the Gmelin and Ballstein books, which were original chemistry sort of databases in the 19th century. They contain inorganic, organic chemistry. Reaxys was launched before the internet era as Crossfire, Ballstein, and so on. And Reaxys as such was launched in 2009. And we have been adding since then lots of functionalities and lots of content. I will tell you finally what's the final shape of it now, but just to mention a couple of important steps, milestones in development of Reaxys is Reaxys medicinal chemistry. This is the module we will talk about today, the module which is containing biological activity of small molecules. Reaxys commercial substances in 2020 added, we have added a database of around 500 suppliers and growing. So you can check commercial availability of chemicals. Huge step in patent expansion in 2021 when we have expanded from some main patent offices to 105 patent offices. And the latest development, which is predictive retrosynthesis, I will talk about this more in detail. The core philosophy of Reaxys is that it tries to deliver you the information you're searching for. It can be the data, it can be information. This is all extracted from the literature, extracted both manually and automatically with using machine learning, using artificial intelligence. If you would want to learn more about this, we can cover this in a separate subject. But just for you to know, Reaxys contains a lot of extracted data, more than any other database. It's all experimental data, mostly. It's all included in the articles or patents, and Reaxys will try to deliver this information. You will see in the examples. We have a new, clean, streamlined user interface, quick search, query builder. So if you would like to get a training on Reaxys, how to use it, please contact me. We can always talk about this in more detail. Today, it's not about the training, it's not about the features. Today, I want to really go into SDGs and show you how Reaxys can support SDGs. But before we do this, I just really need to tell you a little bit more about Reaxys itself. So the interface, clean and easy. I think once users get used to this, I mean, they love it. Students love it. That's what I'm being told. And also, when you search in Reaxys, it will always try to adjust to your question. It will try to interpret your question and try to, using the algorithms, try to give you as good response as possible. If you ask for reactions, if you ask for substances or documents, you will see the response of Reaxys will be different. Extracted information, once again, this is really important. That's why I call Reaxys a pactographic database. It's not a bibliographic database. By the way, it contains data and information from around 4,000 publishers. It contains 16,000 journals, so it's a lot of content. So just to give you all of it in one look, Reaxys is a substance database, first of all, with more than 260 million substances. And then it's a property database, more than 500 million experimental properties. Excuse me. They are distributed into 500 fields and 130 subject areas. So it's really well-structured information, well-indexed information. Then we have a chemical reaction database with more than 62 million single and multi-step reactions, and bibliographic database covering, as I said, 16,000 journals, plus 37 million patents from 105 patent offices. This is the core. We also have pharmacological target database. This is what we call Reaxys targeting by activities, and by activity database. I'll talk about this in more detail in a second. Yes, this is how we want to see Reaxys now. We call it Reaxys Academic Edition, and this edition or this version of Reaxys contains everything. All the content, all the database, also all the by activity and all the prediction, the retrosynthesis prediction. Let's start from quick summary of this. So that's unmatched access to patents, and I already mentioned 105 patent offices, so that's very important. These are available 5 days after publication. Very important. Very quickly, if you look for novelty search, then definitely you want to be up to date. Largest by activity database, I already mentioned. Predictive retrosynthesis, best-in-class tool, and access to chemistry literature from 16,000 journals and 37 million patents. So this is what Reaxys Academic Edition is, and this is how this can support. Focusing a little bit more, before we go to SDGs, focusing a little bit more on predictive retrosynthesis module, which is a very new, and this is the state-of-the-art new module. This is based on all work from many chemists who are working on planning chemical synthesis using the artificial intelligence, and you know, now it's already available. Now this module is available, and it's a winner of Best Chemistry Predictive Analytics Specialist 2020, and this is already working in Reaxys. How it works? This works with 3 neural networks and Monte Carlo research, and this was built using the algorithms trained on 50 million reactions, and the software, this artificial intelligence, automatically created and prioritized rules, and it created around 400,000 reaction rules. The rules driving how the compounds behave, how they can be synthesized, and how they can be maybe divided, and so on. So this is self-learning module, and it's learning on huge amount of reactions available in Reaxys. And final look is like this, for example, where you can run the predictive retrosynthesis, even for the compounds that don't have any published reactions, but also for those that have published routes as well, because maybe you want to go greener, you want to find quicker, more effective reactions with higher yield. You know, in context of SDGs, maybe we're looking for reactions which are, for example, less aggressive to the environment. So this is all very important, and we already start to look into this. And these routes can be viewed in different ways, and you can modify these routes as well. Looking at the bioactivity and you know, DMTA cycle: design, make, obtain, test, and analyze. We obviously also develop a lot of content and then functionality in Reaxys for this, for looking for novelty in terms of the bioactivity search and drug design and so on. So in Reaxys we have more than 43 million bioactivities, And this is manually curated content looking at more than 8 million substances by activity data. So you see there is a lot of data on ADME, on toxicity, on pharmacological assays, species, more than 21,000 cell lines. So this is huge database of biological activity and all related science. And therefore, Reaxys supports questions like which substances interact with my target, pharmacological target, what are the interactions between my substance and the target, which similar substances might have similar bioactivities, and so on and so on. So this leads to really very, very precise and very quick retrieval of the information, which is enhanced by the extractive data as compared to reading articles, extracting and putting this together. So I think that was the introduction, and now we are coming to SDGs, Sustainable Development Goals, and how Reaxys can support these goals. Well, somebody said, actually, Reaxys can support almost all of those. Maybe this is a little bit over-optimistic, but I think there is a good group, solid group of those which are supported in an obvious way by Reaxys, by chemistry research, where chemistry really matters, and therefore where Reaxys matters. This is the SDGs number 2, which is zero hunger, 3, good health and well-being, 6, clean water, sanitation, affordable and clean energy, industry, innovation, infrastructure, responsible consumption and production, and climate action. I believe these are obviously related to chemistry, and chemistry plays a very important role in those. And let's quickly see how Reaxys can support it. Once again, I just stop here for a second. I remind you, you can ask questions. We have a Q&A option here. So if you have any questions in the meantime, don't wait. I mean, of course, I will leave some time at the end, but in the meantime, put them into the Q&A so that we can answer them later. But of course, you can also do that later if you want. So let's go SDG by SDG and see how Reaxys can support it, and see how, in practical terms, it could work. Let's start with SDG 2, zero hunger. So what are we thinking about when we have zero hunger? How practically we can approach this? Well, definitely plants, right? Agriculture, plant protection, maximizing crop production, fertilizers. But also, if you talk zero hunger, you also talk about the already produced stuff, produced food, preserving food, extending food shelf life, making it healthier, right? Using less artificial or more natural ways of preserving food. So there is lots of different areas which are related to agriculture, food contamination, even food storage, and in all those areas, chemistry plays important role, and also Reaxys can help in many different ways. I'm not able to show all of them. I was just trying to find the most obvious ones and show you good examples. Like, for example, when you think about crop production and plant protection, for example, herbicides, pesticides, all these compounds that make sure our crops are healthy. For example, here I was searching for substances with the effect of being, herbicide, for example, and I had for 44,000 substances where the effect is herbicidal. That means that they, in the literature or in the patents, they were reported as those that could have potentially this type of effect. Not necessarily all of them are used like this, because this might be a side effect, or this might be some sort of other research, but at least we have a huge group of compounds which display the herbicidal effect, and we could maybe then sort them, filter them by certain type of substructure, certain type of compounds, group of compounds, and see which of those could be used in practice and which of those could be really used safely, for example. Preventing drought, for example. I was looking at drought prevention and different compounds. I looked at obapactin and other compounds that could lead to prevent the drought effects. And there is not too many articles on this, but I found some important ones that could potentially support research in this area. And for example, like in this case, we have the compound and we have all the information about it, including how to synthesize it. And if synthetic routes are not known yet, we can use the predictive retrosynthesis model, of course, and try to predict how we can synthesize them. But I think, first of all, what we need to know is what its bioactivity, what is toxicity, how it dissolves in water, what is the presence in environment, how, for example, what would be the biodegradation time, and so on and so on. So all these questions will be answered in Reaxys as well. Pesticides are really important and they are necessary. However, they are also toxic, as we know. So looking at pesticide toxicity would be another way of making our lives better and healthier, and trying not to contaminate the soil and environment with the pesticides, with the chemicals that we are using to protect our plants. And also this area of research will be very well covered in Reaxys in many different ways, starting from articles, patents, but also going to substances. And looking at toxicity, we can look at toxicity data, and that's why I said Reaxys is not a bibliographic database, it's actually a factographic database. And when you find information on a specific group of compounds or a compound, and then if you go into bioactivity, this is Reaxys targets and bioactivities functionality here, we can see, for example, the data on toxicity. So you see, you don't need to go into the articles or patents, although you have the links on the right side, and you can easily go there if you have access, of course, to the databases where these articles were originally published, because Reaxys does not have full text, the same like any other bibliographic database, but it will always have a link to full text. But normally there is no need to go there because you see all the data is extracted. So before you go there and look for details, you already know what was the original parameter measured, what was the value, what was the biological species, tissues, organs, dosing, effect, and so on. And here we look at toxicity, which can be represented in many different ways. By the way, here on the left, we have also the PX, which is the unified measure of bioactivity, which can be used to compare different measurements, bioactivity measurements done with different parameters. And then using this PX, using this unified measure of bioactivity, we can compare them regardless of how they were measured, with what type of parameter. I said we can also look at environmental data like abiotic degradation, for example, and look if this compound would degrade quickly or not, and how we could then get rid of this in the soil or in the waters or in the atmosphere. So we could also look at this. So trying to be responsive to environmental needs, trying to be following what happens with the pesticides or any other compounds that we actually do use to protect our crops. I also looked at articles about food preservation. Again, lots of interesting ideas and lots of different research that is happening, like food packaging, for example, using some natural films, for example, to some more natural ways of packaging food or preserving food. So you can get a lot of ideas also on this, how to make the food lasting longer so that more people can use it. And of course, we can get this information, as I said, from many different sources. And here on this example, we have articles, but we have also lots of patents. But we also have conference papers, editorial notes, short surveys, chapters from books, and so on and so on. So you see there is a lot of different sources of this information. Fertilizers, again, within the subject of food and plant protection and plant growth. Here, I was looking on different fertilizers, and this is a very obvious example with urea here, but just wanted to show you how much data and information could be available. Also, again, fertilizers, how they influence soil enzymes, for example, are they not acting against the the nature, and how can we prevent it? So there is a lot of good amount of research on this as well. Going into SDG 3, good health and well-being. I was looking at it from different point of view, like greener chemical manufacturing, drug development, reduction of air pollution, for example, right? So here, just an example that when you search for a reaction in Reaxys, you will always have a chance to select reactions with a specific solvent or catalyst or reagent. But of course, you also can select classes of catalysts and classes of solvents. And the classes of solvents are really important because here you can select green solvents as well. And if you click on view more, you can even select which green solvents you would want to use in your reaction. And then you will only get the set of reactions which are fulfilling your criteria. So criterion of greener chemical manufacturing. And this can be very easily filtered so that you get the information. Solvent recycling, right? So again, trying to make greener chemistry. Lots of articles, 1,200 articles on solvent recycling. So you can really check how this works, look into the patent information, look into the reactions and reaction conditions, and see what you can do with this, which kind of systems you can use. Everything is there. The next interesting area where we could use Reaxys, enzymatic reactions, rather than going into aggressive chemicals, trying to use enzymes, organisms, and trying to be more nature-friendly again. So we have all these organisms, enzymes in Reaxys as well. So it's very easy to search for enzymatic reactions. For example, very simple one, enzymatic reactions of glucose. I was searching for the reactions starting with glucose and which have any mention of enzyme or enzymatic reaction or enzyme kinetics in it. And I found many different reactions looking at this type of reaction. Drug development, of course, starting from looking at inhibitors, looking at pharmacological targets, like in this case of COX-2, looking at pharmacological targets and starting from the substances which could act on this target. And also it's very easy to also find a specific type of action on target, like inhibition, blocking, or any other biomarkers and so on. So we can find these compounds very easily. In this case, I was looking at selectivity profile as well, where we were searching for compounds active on COX-2, not active on COX-1. With this selectivity profile, you can easily see, and also including this bioactivity visualization, you can quickly see where you have high selectivity on a specific pharmacological target. This data is usually coming from hundreds of thousands of articles. So one search in Reaxys, one visualization gives you the data that you would need to get, or in order to get it, you would need to find, download, search hundreds of thousands of articles. So this is the information which can be obtained in a matter of minutes. In terms of drug development, looking at certain drugs, here I was looking at drugs containing COVID in a description, in any type of a description, and looking for drugs that were already reported as related to COVID. And then it's mostly patents that I found. And this information allows you to find the record of the substance, where you can go and look for drug likeness, bioactivity data, physical data, all the properties, physical-chemical properties, spectra information, all the other data, analytical data, if you want to analyze this in many different ways. All the preparations, so how can I synthesize it, reactions with this compound in a different role, all pharmacological targets which are reported for this compound, and also the documents about it. So you have all the information in the substance record in one place. And here I was looking, for example, at drug synthesis. How can we synthesize it? And again, 117 reactions available, plus what we could do, we could go into predictive retrosynthesis module and try to find reactions which are not published yet. For reactions that have experimental procedures, we also extract them, and you will get this experimental procedure extracted directly in Reaxys. So again, you don't need to go to original document, article, or patent, because the experimental procedure, if it's there, it will be extracted. So you can go straight to the lab and try to repeat this. What you can also do when you do this synthesis, you can try to use the commercial availability module. I already mentioned this in the beginning. So there's the module containing supplier information. We have around 500 suppliers in the system, and you can check commercial availability of the compound, looking at different suppliers, different purity, packaging, prices, availability, and wherever possible, you will get the link also to SDGs, safety data sheets. So as much information as possible. Of course, there is also the link to supplier site, and you can go directly to their webpage and to their shop and see directly there, look for this chemical. I was also looking for air pollution, thinking about the healthy living, and here we have many documents, too many. So it seems like this search was too generic, but I could start generic search and then go into filters and try to look for additional keywords so that I could be more exact in my search and try to look at different ways how the air pollution could be minimized. More exact type of search, like indoor volatile organic compound removal. So how can we get rid of the compounds, the toxins that we have in indoors, which are resulting from many different sources, like glues, furniture, maybe plastics that we use, and so on. So this is also quite important subject. Even more practical application, absorption of gases on solid sorbents. So this example shows Reaxys is not just the organic reaction database. It's organic, inorganic, but it's also physical chemistry. It's basically all areas of chemistry, covers all chemistry, including like here, like surface phenomena, adsorption. And here I was, sorry, I didn't switch off my phone. So here I was looking at adsorption of carbon dioxide on zeolites. By doing this search, I found a lot of information on adsorption data, and a lot of details on the type of zeolite, because they can be in different forms. And this already gave me a lot of ideas on which zeolites and where do I find information. Of course, link to the original document on the right. There is always this link to original source of information. Going to SDG number 6, clean water and sanitation, water purification and desalination, for example. Water purification, desalination, separation methods for removal of pollutants. This becomes now more like material science, but still I was looking for water purification, water desalination, using, for example, nanotubes. Here you can see the example of a search that can be done in a query builder in an advanced search tool. Again, this is not a training now. I don't want to go into details, but just to show you how sophisticated search tools are available in Reaxys, so that you can really ask your question very, very exact. And in this case, I found articles that were talking about using nanotubes for water desalination or water purification. And many articles were spot on what I was looking for. Looking MOFs for removal of heavy metals. Again, there are different ways of purifying water. This could be MOFs are also a good idea, and there is a lot of research as well on removing heavy metals from water, for example. So again, articles, documents where you see the abstract, where you see the index terms, and of course you have the link to full text. You can use the filters, different types of filters where you can check, and you can even further make this result set more fitting to your question. Separation methods for pollutants removal. Again, pollutant separation methods, lots of articles, and I did it on purpose just to see what's in a subject, and then going into filters, trying to filter for these different pollutants and see how this gives me the idea of what can be done here with these articles. And you can see I found 76,000 documents. So again, this is a huge source of information, and I would need to be a little bit more exact on what would my pollutant be, or what the separation method could be. I could then go and try to be more specific on this, but I really wanted to show you how much information is in Reaxys. So that you don't just use it for reactions or for exact substance examination, but you can also do the full literature review using Reaxys, and this doesn't have to be only organic synthesis. It can be really a very, very wide area of application. Okay, SDG number 7, affordable and clean energy. And here we look at clean energy, advanced materials for renewable energy, photovoltaics, wind turbines, thermal, energy collection, batteries, supercapacitors, energy storage solutions, and so on. This all sounds like technology subjects, but they all start with chemistry, and they all start with some compounds that need to be used, that could then be produced in a practical way to produce those. And here I was looking, for example, for clean fuel, almost 3,000 documents on clean fuel methodologies, or, for example, looking at advanced materials for energy storage. And advanced materials for an energy storage, for example, metal sulfur batteries, which become a subject now, and metal organic frameworks again, with different rare metals and so on. So all these different types of searches, and I could find always lots of content on this, even sometimes too much. However, of course, after using filters or maybe asking the question a little bit more exactly, you find all this information very, very easily. Practical applications, lithium-ion batteries, for example, quite easy to find. And again, I show you how this is constructed in a query builder in our advanced tool. And here I was looking for a molecular formula containing lithium, manganese, oxides. So you see this formula written here, and the use which starts with batteries. So I was looking for all these compounds that could potentially be used in lithium-ion batteries, lithium manganese, actually oxide batteries, and found a lot of information on different compounds that were supporting this idea, and found a lot of different applications of those compounds I also could extend my search to add any other atoms and see if addition of other atoms would change the properties of those compounds again. And for each of them, I would go into physical properties, physical data, and would analyze their properties and see which could be used for this specific use. Thermal energy collection, again, solar energy harvesting, for example, using nanowires. Again, a huge subject in SDGs, and trying to use the natural energy, greener energy harvesting. So these are big subjects, and could be used to produce and to construct new energy harvesting tools, energy banks, for example. So again, 92 documents. Sounds like not too many, but they give a lot of insights into this area. Number 9, industry innovation infrastructure, innovative, sustainable, resilient, advanced materials, coatings, antibacterial coatings, for example, which are important for different applications. So antibacterial coatings derived from different compounds, also formulation of those different levels of crystallization, nano compounds, nanoparticles. So all these different ways of producing these antibacterial coatings, and all of this information would be very easily found. And for my search on antibacterial coatings, I have found only on this type of search, I found more than 3,500 documents. And of course, among those were many patents. So you see, there is a lot of practical applications that can be covered by Reaxys. Antibacterial coatings for medical use, like for catheters, for example. And again, we could use the knowledge which is contained in those articles, like in this one, like fabrication of this polylysine-based antibacterial coatings. And here we also have some compounds, we will have some reactions, we'll have some ideas. So how, starting from chemistry, we can go into more material science and produce these antibacterial coatings that could be used, for example, like in this case, for catheters. So many different approaches. As you can see, we started from agriculture, went through drug development, through environmental science, through antibacterial coatings, food, and so on. And yeah, here's some more information on antibacterial coatings as well. And again, all this substance record gives us all the information that we can use on a substance. I already talked about physical data spectra and so on. Here on the left, under the substance, we also can go directly into the commercial substances, which I described, but we can also go into synthetic routes and try to synthesize these compounds, including the predictive retrosynthesis as well. Like in this case, synthetic routes, looking at reactions and see how this works with experimental procedures again, and looking at the conditions, yield, and also looking at stages of the reaction and in what conditions, what was the reagents, what were the catalysts and conditions like temperature, pressure, and time. We also could try to analyze this and look at different types of methods, analytical methods, starting from separation methods, thermal methods, chromatography, spectroscopy. Like in this case, we have all different types of spectroscopy, and like UVs and basically any type of spectroscopy, and also use of the substance, right? So there is another way of looking at the substance, which looks at how these substances are used. So wherever we find information on specific use of the substance, it will be also collected in the field called use or use pattern. And then we will see how the substance could be used. So allows very practical applications. If we're looking for a very specific type of application like SARS virus, coronavirus in this case, but we could be looking at food additive, again, agriculture use, in material science, basically in any type of different use, we will see this, how the substance is already used. Again, antibacterial coatings, absorption data as well. So how these coatings would be also related to adsorption, how they would behave in all these conditions. We can see on, for example, adsorption isotherms. We will not see the picture of it, but we see the information on it, and we see the diagram, and we see where this information is included. So we extract data into Reaxys. The drawings or diagrams are not extracted, but the information about them and where to find them, which document, in case of patents, also in which paragraph on which page, because patents can be very, very lengthy. So for this, we can also drive your attention or basically point you directly to the source. And it's in case of articles, of course, it depends on the, as I said, on availability of these articles in your institution, or which databases, full text databases are subscribed. In case of patents, the full text link takes you directly to the patent office, where usually these documents are in open access. And yeah, looking, still going with antibacterial coatings, looking, for example, at their toxicity, again, checking if they couldn't be toxic in any way. So all the parameters here on the toxicity, you see the parameter measured, you see the units, biological species, if this was reported, cell lines, if they were reported, dosing, effect, and here you see cytotoxic agent, for example. And as usual, the references on the right side. And these tables can be easily exported to Excel, for example, where you can analyze all this content coming from hundreds of articles. You can have it in Excel in a matter of minutes, and you can analyze the content rather than go through the articles and try to find the information. Yeah, to complete this antibacterial coatings story, of course, you would also want to maybe search for chemicals again. So here we can go into supplier information and try to find this again. So not only how can we synthesize it, but maybe how can we purchase it, or if we want to purchase only the starting materials for our synthesis, then how to synthesize it, check the toxicity, check the use cases, and all full information is available. SDG number 12, responsible consumption and production. Again, prevention of food loss and waste, recycling, food packaging, food additives. So I think this is, again, lots of very important subjects. Some of them were already partially covered in a previous SDGs as well. Here, it's more looking at waste reduction and starting from articles which describe consumer behaviors. So not really pure chemistry, more related subjects, but it's also available. And then from there, we can look at waste reduction and how this waste reduction can be reduced. And then trying to see how can we analyze first the reasons or causes of the food waste, and then trying to decrease it by different methods. And food packaging, proper food packaging could be one method. We already looked at this in, I think, SDG 3, and food packaging is a very important subject. And it's not only just to package it, but just to make sure that this packaging is environmentally friendly, but it's also sustainable, and it's also as natural as possible, but also preventing our food as good as possible. For example, natural fibers, and this is in the climate action, but natural fibers were also mentioned in the context of food prevention. Here, enable. Wait, I have to. Okay. Enable different ways of producing advanced materials, improve treatment of diseases, yield seeds and fertilizers. So everything that goes to in the direction of climate action, of preventing climate deterioration. And here, for example, using of natural fibers, reducing the carbon footprint, and trying to find more natural ways to produce not only food, but also to be used in different areas of industry. Like in this case, I was looking for example, automotive applications. So would natural fibers be used to produce cars or parts of the car? And it looks like there is already a good amount of articles on using the natural fibers in automotive application. So this already gives hope that this can be used in the future to reduce the amount of plastics and all these materials that are not very environmentally friendly. So I think I covered all these key all these key SDGs that are related to chemistry. I hope I have shown how Reaxys can support it, and gave some exact examples. Of course, we could come to many different ideas as well, and I think this is just the tip of the iceberg that I showed you, just to prove how using the proper tool you can get this information very quickly. If you want to learn more about Reaxys, I would like to invite you to the YouTube channel. We have YouTube channel for Reaxys. If you just search for Reaxys, you will find it very easily. And there you have lots of videos on different applications of Reaxys and how to use it, so that you can see for yourself how Reaxys can support your work depending on the area of chemistry you are in. So YouTube channel, Reaxys YouTube channel, please check it up and see if this helps. Or you can also go to Reaxys Academy. You see the link on the bottom, elsevier.com/research platforms/academy/Reaxys. Here you can find again lots of material, lots of user guides, videos, and information on Reaxys, how this supports not only research but also teaching. So that's quite important to mention. If you are working in academia, you can easily use Reaxys for supporting your teaching. I know this more modern way of teaching is more related to working on projects rather than just asking students to learn stuff and pass the exam. So this, if you are into this way, you do this modern way of teaching, then Reaxys is definitely supporting this very well. And here the Reaxys Academy is a resource where you can find lots of information. But of course, in any case, you can also ask me. You can write me an email, p.golkiewicz@elsevier.com, and I will be happy to answer and to help you if you would have any questions. So I think I'm more or less in time. Yes, I wanted to leave 10 minutes, last 10 minutes for questions. And let me see if we have one. Okay, we have one question. That's not a question. Thank you, Vasil. Yes, presentation, application. Okay, thank you so much. I mean, so that's okay. That's not a question. That's just a comment. And I see that you liked the possible applications, lot possible uses. Yes, exactly. And I don't think I've been able to touch on all of them. It was just some ideas, some examples. Would be possible for me to show all of them at the same time. So we still have a couple of minutes. Are there any more questions? Would you want to know something more? Really? Okay. I assume it was all clear, and I assume it was all helpful. So if there are no more questions, I can't see any, then I think I will give you back, what, 8 minutes? And thank you so much. And it was a pleasure to host you here. So have a beautiful day, and yeah, goodbye.